Welcome to Unit 3, Rational Expressions and Equations. So just like we did in Unit 2, we're taking what we've learned previously and we're going to build upon it to further the complexity of the expressions and equations that we're writing, which are going to allow us to understand more complex real-world situations. So, think about when we started in Unit 1, we had a very limited amount of real-world situations that we could describe using a quadratic function. And then we learned, about higher degree polynomials, which can, they can do more things, so you can describe more real-world situations. And now we have built up a knowledge base that is going to allow us to create some more complex expressions and equations, which will model, as you might guess, more interesting, more complex real-world situations. So pat yourself on the back. You've done a great job so far. To get us started, we're going to, of course, start with just a little review, some more binomials, do a couple of binomial expansions, or maybe just one, and then move into some new stuff. All right, expand x squared minus 2 to the fifth using the binomial theorem. And just a reminder, do your work on the left side of your paper and save some space on the right side for you to retry the problem where you may have made a mistake. And don't forget to write in questions that you have or places where you get stuck. All right, I hope that went well. This one is tricky, so if you had some questions, that's okay. Don't feel bad. What we want to think about here is exactly what is the a and b value of our binomial here. And what we need to key in on is that the a value is x squared and the b value is negative 2. So when I go ahead and I write out my expansion, and I'll just write it in summation notation, going from k equals 0 to k equals 5. So it's 5 choose k, x squared to the 5 minus k times negative 2 to the k. Alright, and when you expand that out, so that is all going to equal x to the 10th minus 10x to the 8th plus 40 x to the 6th minus 80 x to the 4th plus 80 x squared minus 32. And the thing to notice here is that because our a value was x squared, notice the difference in our expansion. If you look at the exponents, you'll note that it's actually decreasing by 2. Why is that? Well, note that a was x squared, so the exponent is always decreasing by 1. So when it's to the 5th, x squared to the 5th is x to the 10th. And then when it's to the 4th, it's x squared to the 4th, which is x to the 8th. And so because our a value is different here, we are getting a different sort of pattern in our exponents. All right, here we go. Suppose P and Q give the sizes of different animal populations where P is greater than Q. In 1 through 4, determine which of the given pair of expressions is larger, and then briefly explain your reasoning in terms of the two populations. So take your time, go through this one by one, make sure that you are giving each one a try, explaining why you think one might be bigger than the other, and put in questions like I didn't understand exactly which one was bigger, I tried this, and use whatever method that you feel gives you the best chance at answering the question and making sense of it. Okay? So, for example, P plus Q and 2 times P. Okay, just think about that and go ahead and give it a good try, and we'll talk in a little bit. Right, I hope that went well. I want to make sure that for each one of these you have selected one of them, and that you have reasoning behind it. And I'm not actually going to divulge any of the answers right now, but I do want to bring up a strategy that can be helpful in situations like this. Sometimes it's hard to put in your mind that P is bigger than Q in general, and so sometimes it's helpful to just give P and Q a value. So you know P is bigger than Q, and you can be very, very simple. That just means that P is a number bigger than Q. So P and Q could be 2 and 1. And that will allow you to think about these different situations and which one is going to be greater, and then give a rationale for it. Now, you probably noticed that some of these expressions, for example, this is one of them, they are what's called a quotient. All right, something is being divided by something else. And so far, if you think about it, we've really only looked at expressions like P plus Q, or 2P, or something like that, or P plus 50T, right? We haven't looked at equations where something is being divided by something else. And this turns out to be a specific type of expression, which is going to be the focus of this unit. Okay, so as I mentioned, we're looking at a new type of expression, and while it seems new, it's actually something we've been working with the entire time. All the polynomials that we've been working with are in a sense actually rational expressions, but they're just very simple rational expressions. So a rational expression, let's define it. A rational expression is simply the quotient of two polynomials. Okay, and quotient, right? You know what that word means. That means it's the result of division, right? So if you took, for example, 10 and divided it by 3, the answer would be a quotient. Okay, that's an E, by the way. And so if you think about it, right, we've actually been looking at rational expressions this entire time, because when we see a polynomial, it is essentially a polynomial is just a polynomial that's divided by 1, right? So it is, in a sense, a quotient. It's just very, very simple. But now we're going to start looking at more complex situations where you might have a polynomial divided by another polynomial. So let me just go ahead and give you an example here. So for example, we might have an expression like 2x squared divided by x minus 3. And here, notice that it's a quotient of two polynomials. We have a polynomial in the numerator and a polynomial in the denominator. Okay? What I want you to do right now is go ahead and take a minute and write your own example over here to the right. Okay, good. I hope you have a good example that we can talk about in class. And really, it's very simple. It's just a quotient of two polynomials. Okay, and so any polynomial that we have as a numerator or a denominator. And of course, we can use rational expressions in equations. Okay. A rational equation, as you might guess, is an equation that contains a rational expression. Okay. I want you to go ahead and write an example for yourself. Give it a try, and then I'll give you an example as well. Alright, so hopefully you were able to create a rational equation. I'm going to go ahead and write one. So let's say that you had the population, so we'll call it P of x in terms of x, some variable. And this could potentially be x minus, actually it could be x plus 7 divided by 2x, right? And notice here that I have an equation set up where the population, which depends upon x, well, it is actually a quotient. So the way that I would, the relationship between x and p is found by dividing. So here is a question that we're going to take a look at, and you're going to give a try on your own right now. A car makes a trip to a destination that is d miles away. The average speed of the car on the outgoing trip is r sub 1, and the average speed of the car on the return trip is r sub 2. Describe the meaning of each expression. So take your time here. Really just think about each expression and what it is doing with the two values, so how it's relating them. You can even remember that we talked about giving them real tangible values. So make up a value for D, make up a value for R1. It might help you visualize what is actually happening and what this expression will describe. But remember, you want to still talk about it in general, so you don't want to put any specific values in your answer. So go through, take a look at each one. For letter C, there's a lot going on. So break it down piece by piece. Think about each sort of section of the expression individually first, and then put them all together and see how they relate. So again, the big picture idea is that you want to describe what each expression means in terms of the trip. Okay, so make sure that you have an attempt at each one. If you have questions that arise, make sure that you have a question bubble ready to go, and we will talk about it in class. Okay, so we've got one more problem to take a look at. I hope that went well. Alright, so last one for us to think about. So consider the rational expression below. Are there any values of x for which you cannot compute the rational expression? Explain how you know. So think about this one. Consider some different x values. Maybe try some out. Here, split your paper in half again. Do your work on the left. We're going to talk about this one in just a second. At the very least, try some values out. See if there are any. If nothing comes to mind immediately, try some x values out and see if you can compute. And we'll talk about it in just a little bit. Okay. Well, I hope that went well. So we have to think about what is a rational expression again. A rational expression, of course, is a quotient, right? It's something divided by something else. So I have a polynomial on top in my numerator and a polynomial in the denominator, and I'm dividing the values of the two. So I will take the value of the numerator and divide it by the value of the denominator. And so this is nothing more than a division, a fraction in a sense. And so I want you to think, pause the video and think, what's a fraction that you can't compute? Okay, if you haven't, I want you to try and write down a fraction on the left side of your paper that you cannot compute the value of. Okay, hopefully you thought about a fraction like this. Let's give us an example. Consider a fraction like 2 over 0. You can't compute 2 over 0. Why is that? This is saying take 2 and divide it by 0. In other words, divide 2 by 0. But how many times, is what it means, how many times will 0 go into 2? Well, think about what that means. That's saying, what could you multiply 0 by to get 2? But there's nothing, because anything times 0 is 0. And so you can't figure out this value. right? It does not exist, okay? And so in math, we'll use the term does not exist. And this is, we use D and E to connote that. And so we want to think about what are some values that would make this expression not exist. And so just like with fractions, since this is nothing more than a fraction, any x value that will make our denominator 0 will be an expression that just doesn't exist. And so the question boils down to what will make our denominator 0 in this case? Well, you could try a few values out, but you might just think, okay, well, what will make the denominator 0, right? What will make this 0? And note that anything, what squared would be 0, since this is something squared? Well, 0 squared is certainly 0. So what will make x minus 2 into 0, right? So if you think about it, what I'm wondering is, how do I solve x minus 2 is equal to 0? And that just boils down to, I add 2 on both sides when x is 2, right? When x is 2, imagine plugging that in here. When x is 2, let's actually do that. So when x is equal to 2, well, we'll have 2 minus 1 divided by 2 minus 2 squared, which is equal to 1 over 0 squared, which is 0. And this does not exist. Okay? And so this is actually a term. It's what's called an excluded value. So an excluded value is any value for which an expression does not exist. Another way of saying that, or another way of saying that is undefined. The word undefined means not defined, right? You can't say what it is, so it does not exist or it is undefined. And for a rational expression, when is this? So I want you to go ahead and write down when a rational expression is going to not exist, when it's going to be undefined. What are the excluded values for a rational expression? Try and write that down now. Okay, I hope you were able to give that a try. So an excluded value for a rational expression is going to be any value which makes the denominator equal to 0. Okay? So for a rational expression, any value which makes the denominator 0 is an excluded value. All right, here's one more. So consider the rational expression below. For what values is the expression undefined, or does it not exist? And explain. Go ahead and have your answer written out and some questions ready to go, and we'll see you tomorrow. And one other quick note that you want to be aware of is that we're going to do a quick quiz on the binomial theorem. So be ready for that. Make sure you've done the question at the front, and that'll be very quick, maybe 3-4 minutes right at the beginning of class.